The first time Oberleutnant Franz Dietrich saw a P-47 Thunderbolt up close, he thought it was some kind of mistake. The American fighter sat on a captured airfield in France, August 1944, its massive radial engine cowling, gleaming dully in the afternoon sun. Franz had been sent to inspect the aircraft as part of the Luftwaffe's Technical Intelligence Unit, tasked with understanding why Germany was losing the air war so catastrophically. He walked around the beast slowly, notebook in hand, measuring, photographing, calculating. The P-47 was enormous for a single-engine fighter, weighing nearly 8 tons fully loaded. Its fuselage was thick and barrel-shaped, lacking the sleek elegance of the Messerschmitt Bf 109 or the purposeful lines of the Focke-Wulf FW 190. To Franz's trained eye, it looked like something that should never fly, much less dominate the skies over Europe. But dominate it did. And as he climbed onto the wing and peered into the cockpit, then walked back to examine the engine, Franz began to understand why. The secret wasn't in the airframe design or the armament, though both were formidable. The secret was buried deep in the engine compartment, in a piece of machinery so advanced that German engineers had been trying unsuccessfully to replicate it for 2 years. This is the story of that secret and of the aircraft it powered into legend. The story of the P-47 Thunderbolt begins not with the aircraft itself, but with an engine that would revolutionize aviation. In the late 1930s, the Pratt & Whitney company was working on a radial engine that would become the most powerful piston aircraft engine ever mass-produced, the R-2800 Wasp. The R-2800 was a marvel of engineering. It featured 18 cylinders arranged in 2 rows, each cylinder precisely machined to tolerances measured in thousandths of an inch. The engine displaced 2,800 cubic inches, hence its designation, and in its early variants produced 2,000 horsepower. But power alone wasn't what made the R-2800 special. What made it revolutionary was how that power was delivered at altitude. Most piston engines lose power as they climb higher. The air becomes thinner, providing less oxygen for combustion. By 20,000 feet, a naturally aspirated engine might produce only half its sea level power. This was a critical problem for fighter aircraft, which needed to climb high to intercept enemy bombers. The solution was supercharging, forcing more air into the engine to compensate for the thin atmosphere. But here's where the R-2800 became something truly special. Pratt & Whitney engineers didn't just add a supercharger. They developed a turbo-supercharger system so advanced that it would take German engineers years to understand, and they would never successfully copy it. Alexander Kartveli, the brilliant Georgian-American engineer at Republic Aviation, saw the potential immediately. In 1940, he began designing a fighter around the massive R-2800 engine and its revolutionary turbo-supercharger. The result was the XP-47B, the prototype that would become the P-47 Thunderbolt. The aircraft first flew on May 6, 1941. Test pilot Lowry Brabham lifted the heavy fighter off the runway at Farmingdale, Long Island, and immediately knew he was flying something extraordinary. Despite weighing 12,500 pounds empty, nearly twice the weight of contemporary fighters, the XP-47B climbed eagerly. More importantly, it kept climbing with minimal power loss all the way to 40,000 feet, a ceiling no other fighter in the world could match while maintaining combat effectiveness. The key to the P-47's performance lay in its turbo-supercharging system, and understanding this system requires understanding the fundamental problem it solved. When an engine runs, it consumes air and fuel, produces power through combustion, and exhausts hot gases. In most aircraft, those exhaust gases were simply vented overboard, their energy wasted. The turbo-supercharger recaptured that wasted energy. The exhaust gases, still moving at tremendous velocity and temperature, were directed into a turbine wheel. This turbine spun at incredible speeds, often exceeding 20,000 revolutions per minute. The turbine was connected by a shaft to a compressor wheel, which compressed incoming air and forced it into the engine's supercharger. This might sound straightforward, but the engineering challenges were immense. The turbine had to withstand temperatures exceeding 1,500 degrees Fahrenheit while spinning fast enough that its outer edges approached supersonic velocities. The compressor had to deliver precisely controlled air pressure to the engine, varying with altitude and throttle setting. The entire system had to be lightweight, reliable, and controllable by the pilot through a single lever. In the P-47, the turbo-supercharger was mounted in the rear fuselage, which is why the Thunderbolt had such a deep belly and long tail. Ducting ran from the engine exhausts along both sides of the cockpit back to the turbine. Other ducting brought compressed air forward from the compressor back to the engine. This arrangement required approximately 15 feet of ducting, all of which had to be carefully designed to minimize pressure losses. The system's brain was the turbo regulator, a mechanical computer that automatically adjusted the turbine's speed to maintain optimal boost pressure. This device used a combination of springs, diaphragms, and valves to sense both manifold pressure and altitude, making adjustments thousands of times per minute. It was a masterpiece of mechanical engineering, manufactured to tolerances that challenged even American industry's capabilities. German engineers captured their first intact P-47 in late 1943. When they dismantled it and discovered the turbo-supercharger system, they were shocked. Not because they didn't understand the principle. German engineers had experimented with turbo-supercharging since the 1920s, but because of the execution. The material science, the precision manufacturing, and the automatic control systems were all beyond Germany's industrial capabilities by that point in the war. The first P-47C Thunderbolts arrived in England in December 1942, equipping the 56th Fighter Group at Horsham St. Faith. The American pilots, most of whom had trained in nimble fighters like the Curtiss P-40, were dismayed by their new mount. The P-47 seemed enormous, heavy, and clumsy. Pilots nicknamed it the Jug, short for Juggernaut, and not always affectionately. Their first missions did little to improve opinions. The P-47s were assigned to high-altitude bomber escort, and while they performed adequately, they seemed to lack the agility to dogfight with German fighters. When German pilots dove away from combat, the heavy Thunderbolts were too slow to catch them. The Luftwaffe quickly learned to avoid combat with P-47s at high altitude, but could simply dive away when threatened. Then the Americans discovered what their aircraft could really do. The P-47's weight, which seemed such a disadvantage, became a devastating asset in a dive. The Thunderbolt could outdive any German fighter in service. More importantly, it could pull out of that dive at speeds that would tear the wings off a Messerschmitt or Focke-Wulf. The massive radial engine and sturdy construction could withstand maneuvers that would destroy other aircraft. Lieutenant Robert Johnson of the 56th Fighter Group discovered another advantage on June 26, 1943. Returning from a mission over France, his P-47 was attacked by Focke-Wulf FW-190s. The German fighters poured cannon and machine gun fire into Johnson's Thunderbolt. They hit the aircraft repeatedly, destroying the radio, punching holes through the fuselage, and shattering the canopy. Johnson was wounded by shell fragments, but the P-47 kept flying. The robust R-2800 engine kept running, despite taking hits. The aircraft's structure held together despite having hundreds of holes punched through it. Johnson made it back to England and landed safely. When ground crews examined his aircraft, they counted over 200 bullet and cannon shell strikes. Any other Allied fighter would have been destroyed, but the Thunderbolt's rugged construction had saved Johnson's life. Stories like this spread quickly among P-47 pilots. The Jug might not be the most elegant fighter in the sky, but it would bring you home when other aircraft wouldn't. Pilots began to trust their mounts, and trust led to confidence. Confident pilots flew more aggressively, and aggressive tactics brought results. In a concrete bunker beneath the Rechlin airfield, Germany's premier test facility, a team of engineers gathered around the captured P-47. It was early 1944, and the Luftwaffe was desperate for solutions. American fighters were appearing in growing numbers, and German aircraft were being shot down at an unsustainable rate. Oberingenieur Klaus Hoffmann led the examination. A veteran of Messerschmitt's design bureau, Klaus had helped develop the Bf-109's fuel injection system and had worked on supercharger development. He understood engines intimately, which is why examining the P-47's power plant filled him with a mixture of admiration and despair. The R-2800 engine itself was impressive enough. Its 18 cylinders were machined from forgings of exceptional quality. The aluminum alloy was clearly superior to anything Germany could produce in quantity by 1944. But that wasn't what troubled Klaus most. Germany could, with effort, copy the engine's basic design. What Germany couldn't copy was the turbo-supercharger system. Klaus and his team spent weeks dismantling, measuring, and analyzing every component. They understood the theory perfectly. Germany had produced some turbo-supercharged aircraft, most notably the high-altitude Junkers Ju 86P reconnaissance plane. But the P-47 system was generations ahead. The turbine wheel was made from an exotic alloy that could withstand sustained operation at temperatures that would melt German turbine materials within minutes. Analysis revealed it contained chromium, cobalt, and other rare elements in precisely controlled proportions. The manufacturing process involved casting, forging, and heat treatment steps that Germany's war-strained industry couldn't replicate. The ducting was made from stamped and welded steel, formed into complex curves without wrinkles or weak points. The joints were perfectly sealed, maintaining pressure even as the ductwork flexed and vibrated during flight. German attempts to manufacture similar ducting resulted in leaks, cracks, and failures. But the turbo regulator was what truly stunned Klaus and his team. This mechanical marvel responded to changes in altitude and throttle position automatically, maintaining optimal boost pressure without pilot intervention. German engineers took one apart, photographed every component, measured every spring rate and diaphragm thickness. They understood how it worked in principle. Building one that actually worked reliably proved impossible. The close tolerances required precision manufacturing beyond Germany's capabilities in 1944. The materials needed were either unavailable or allocated to other critical war production. Even when they managed to construct a prototype, it was unreliable, prone to surging, and dangerous to use in combat. Klaus wrote a detailed report for the Reichs Luftfahrtministerium, the German Air Ministry. His conclusion was stark. Germany could not copy the P-47's turbo-supercharger system with available resources and industrial capacity. The report was filed away, one more piece of evidence that Germany was losing the technological war along with the shooting war. As 1943 progressed into 1944, the P-47 evolved rapidly. The early C and D models gave way to more advanced variants. External fuel tanks extended range, allowing the Thunderbolts to escort bombers all the way to targets deep in Germany. Water injection systems temporarily boosted engine power for combat, pushing output to 2,300 horsepower or more for brief periods. The P-47 D-25, introduced in mid-1944, featured a bubble canopy that gave pilots all-around visibility matching or exceeding any fighter in the world. The aircraft's 850 caliber machine guns, 4 in each wing, could carry 3,400 rounds of ammunition, enough for sustained combat. Pilots discovered that the Thunderbolt's guns could be harmonized to converge at various distances, creating a devastating cone of fire. But the most significant evolution was in how pilots used their aircraft. The P-47's combination of speed, firepower, and survivability made it ideal for ground attack. Pilots began experimenting with dive bombing, rocket attacks, and strafing runs against ground targets. The Thunderbolt could carry up to 2,500 pounds of bombs or 10 5-inch rockets while maintaining reasonable performance. In the ground attack role, the P-47 found its true calling. The rugged construction that made it survive aerial combat also made it survive ground fire. The powerful engine could keep running despite battle damage. The massive amount of ammunition allowed sustained strafing attacks. Thunderbolts ranged across occupied Europe, attacking trains, trucks, tanks, and anything else that moved. German forces learned to fear the distinctive sound of a P-47's engine. Unlike the high-pitched scream of inline engines, the R-2800 radial produced a deep, threatening rumble that announced the Thunderbolt's presence from miles away. When that sound was heard, German troops scrambled for cover, knowing that 8 machine guns and a ton of bombs were likely inbound. The 9th Air Force, created specifically for tactical air support of ground forces, equipped many of its fighter groups with P-47s. These aircraft flew thousands of sorties supporting the D-Day invasion and the subsequent campaign across France. They attacked German positions ahead of advancing Allied troops interdicted supply lines, and provided close air support when ground forces encountered resistance. Statistics from this period tell the story. P-47s flew more sorties than any other American fighter type in Europe. They destroyed more ground targets than any other Allied aircraft. And crucially, they lost fewer aircraft per sortie flown than lighter, more agile fighters. The Thunderbolt's survivability meant that experienced pilots lived to fly again, accumulating expertise that made them even more effective. To understand why the Germans couldn't copy the P-47's engine system, we must understand what made the R2800 and its turbo-supercharger so special in technical terms. This requires delving into engineering details that reveal just how far ahead American industrial technology had advanced by the 1940s. The R2800 cylinders were forged from aluminum alloy, then machined to final dimensions. Each cylinder incorporated a steel sleeve that formed the actual combustion chamber, pressed into the aluminum head assembly. The valves were made from high-temperature steel alloys, precisely machined and lapped to ensure perfect sealing. Each valve was operated by a push rod and rocker arm assembly, all manufactured to tolerances of plus or minus 0.002 of an inch. The crankshaft was forged from a special steel alloy, then machined and heat-treated to achieve the necessary strength. It incorporated 9 throws, one for each pair of opposed cylinders, and was dynamically balanced to minimize vibration. The crankshaft rode on main bearings made from lead-bronze alloy, which could withstand the tremendous loads generated by 2,000 horsepower while maintaining precise clearances. The supercharger, mounted on the rear of the engine, was a centrifugal type featuring a single impeller that spun it up to 10 times the engine's crankshaft speed, driven through a gear train. The impeller was precision cast from aluminum alloy, then machined to final dimensions and carefully balanced. Even minor imperfections would cause vibration and failure at operational speeds. Now add the turbo-supercharger to this already complex system. The exhaust from all 18 cylinders had to be collected and directed to the turbine without creating excessive back pressure that would reduce engine power. The turbine wheel, spinning at over 20,000 RPM in a 1,500-degree exhaust stream, required exotic metallurgy. Analysis of captured P-47 turbines revealed they were made from a nickel-chromium-cobalt alloy that maintained strength and resisted oxidation at extreme temperatures. The compressor wheel, connected to the turbine by a shaft running through a bearing assembly, had to spin at the same tremendous speed while pumping air at pressures up to 20 pounds per square inch above atmospheric. The compressed air became extremely hot, so an intercooler was necessary to cool it before feeding it to the engine. This intercooler was a heat exchanger using ram air from the aircraft's forward motion, requiring careful aerodynamic design to minimize drag. The control system tied everything together. The turbo regulator sensed manifold pressure through a line running from the engine intake. It sensed altitude through an aneroid capsule, a sealed chamber that expanded or contracted with changes in atmospheric pressure. These inputs controlled a wastegate valve that could bypass exhaust gases around the turbine, regulating its speed and thus the boost pressure delivered to the engine. This entire system had to work reliably at altitudes from sea level to 40,000 feet, in temperatures from minus 60 degrees Fahrenheit to plus 100 degrees, during violent combat maneuvers that subjected every component to rapidly changing loads and vibrations. And it had to do all this while being light enough for a single-engine fighter, efficient enough to not waste precious fuel, and simple enough that a pilot could control it with a single lever. Germany's industrial infrastructure in 1944 simply couldn't produce such a system in quantity. The precision manufacturing required exceeded what war-strained German factories could achieve. The special alloys needed materials that Germany couldn't import due to the Allied blockade. The production volume needed to equip thousands of aircraft was beyond Germany's capacity, even if they could solve the technical problems. While engineers understood the P-47's technical superiority, pilots transformed that superiority into victory through skill, courage, and hard-won experience. The men who flew the Thunderbolt into combat came from every corner of America and beyond, unified by their willingness to climb into a 7-ton fighter and challenge the Luftwaffe over its own territory. Captain Don Gentile of the 4th Fighter Group was one of the early aces in the P-47. An aggressive pilot with exceptional shooting accuracy, Gentile learned to use the Thunderbolt's strengths in combat. He would position his flight at high altitude, using the P-47's excellent high-altitude performance. When enemy fighters were spotted below, Gentile would lead his flight into a dive, using the Thunderbolt's tremendous diving speed to catch opponents before they could react. In combat, Gentile used the P-47's 8 machine guns with devastating effect. He would close to point-blank range, often within 200 yards before opening fire. At that range, the concentrated fire from 8 guns could destroy any aircraft with a single burst. Gentile scored 19 victories in the P-47 before transitioning to the P-51 Mustang, but he always maintained that the Thunderbolt was the superior fighter for aggressive pilots. Colonel Hubert Zemke commanded the 56th Fighter Group, the top-scoring P-47 unit in Europe, with 674 confirmed aerial victories. Zemke was a superb leader who understood both the aircraft's capabilities and how to employ them tactically. He developed the formation tactics that became standard for P-47 units, emphasizing mutual support and the use of altitude advantage. Under Zemke's leadership, the 56th Fighter Group became known as Zemke's Wolfpack. They painted distinctive checkerboard patterns on their aircraft cowlings and developed a reputation for aggressive combat. Zemke insisted that his pilots master every aspect of the P-47's performance envelope. They practiced high-altitude formation flying, high-speed dives, and the aircraft's combat capabilities until every pilot could extract maximum performance. Lieutenant Colonel Francis Gabreski was the top American ace in Europe, flying the P-47, with 28 confirmed victories. Gabreski's success came from patience and discipline. He would stalk enemy formations, waiting for the perfect opportunity to attack. When he struck, it was from an advantageous position, often out of the sun, using surprise and the P-47's speed to engage and destroy enemy aircraft before they could effectively respond. Gabreski understood that the P-47 wasn't a turning fighter. He avoided prolonged dogfights where lighter German fighters could use their superior maneuverability. Instead, he fought using boom and zoom tactics, diving from altitude, making a single high-speed attack, then climbing back to altitude using the Thunderbolt's excellent zoom climb capability. This fighting style maximized the P-47's strengths while minimizing exposure to enemy fire. In the Pacific theater, the P-47 served with equal distinction. The rugged construction that made it survive over Europe proved equally valuable in the harsh conditions of the Southwest Pacific. Thunderbolts operated from primitive jungle airstrips, where their robust landing gear and structure withstood rough conditions that grounded more delicate aircraft. The P-47's range, extended by drop tanks, allowed it to escort bombers on long missions over the Pacific. The powerful engine kept working in the humid tropical heat that caused other engines to overheat. And when Japanese aircraft were encountered, the Thunderbolt's diving speed and firepower proved just as effective against Japanese fighters as they had against German ones. As the P-47 established dominance over European skies, the Luftwaffe struggled to develop effective countermeasures. German pilots tried various tactics, but the Thunderbolt's combination of performance, firepower, and survivability defied easy solutions. Early in the air campaign, Luftwaffe pilots attempted to attack P-47 formations head-on, hoping to use their cannon-armed fighters' heavier firepower to destroy Thunderbolts before they could engage. This tactic occasionally succeeded, but proved costly. The P-47's 8 machine guns created a dense cone of fire that was deadly even in brief head-on passes. More importantly, the Thunderbolt's rugged construction meant it could survive hits that would destroy lighter fighters. Major Hans Philipp, a Luftwaffe ace with over 200 victories, wrote in his combat diary about encountering P-47s. The American fighters are very difficult to bring down. They can absorb tremendous punishment and continue fighting. Their pilots are becoming more aggressive and skillful. Our previous advantages in experience and aircraft performance are disappearing. Phillips' observation was prescient. As American pilots gained experience, they learned to exploit every advantage the P-47 offered. The Luftwaffe's veteran pilots, who had dominated the skies in earlier years, found themselves facing opponents in superior aircraft who were learning and adapting with alarming speed. German aircraft designers attempted to develop fighters that could match the P-47's high-altitude performance. The Focke-Wulf Ta-152, a high-altitude variant of the WWII, featured a pressurized cockpit and boosted engine capable of excellent performance above 30,000 feet. But the Ta-152 arrived too late and in too few numbers to make any difference. Less than 200 were built before the war ended. Messerschmitt developed the Bf-109H, another high-altitude variant with extended wings and a boosted engine. It never entered production. The reality was that Germany lacked the industrial capacity and resources to develop and mass-produce aircraft competitive with American designs. Even when German engineers created excellent designs, manufacturing them in quantity proved impossible. The Luftwaffe also experimented with heavily armed and armored fighters designed specifically to attack American bomber formations while avoiding the escort fighters. The Focke-Wulf FW190A-8/R2 carried 4 20mm cannons and 2 13mm machine guns, along with armor plating to protect the pilot from defensive fire. These Sturmbach fighters could destroy bombers with devastating effectiveness. But the Sturmbach fighters were vulnerable to the very escorts they were supposed to avoid. Heavy and slow maneuvering due to their armor and guns, they were easy prey for P-47s. American fighter pilots quickly learned to attack these heavily armed bombers-destroyers, shooting them down before they could engage the bombers. The tactic failed, and with it went one of the Luftwaffe's last hopes for stemming the bomber offensive. By mid-1944, the Luftwaffe was in retreat. Experienced pilots had been killed or captured at an unsustainable rate. Fuel shortages limited training for replacement pilots, who arrived at combat units with minimal flying experience. Aircraft production couldn't keep pace with losses, and over everything flew the P-47 Thunderbolts, along with P-51 Mustangs and P-38 Lightnings, dominating the skies and attacking anything that moved. The P-47's turbo-supercharger system represented a technological leap that influenced aircraft design for decades. Understanding why requires examining what happened after World War II when engineers applied lessons learned to new generations of aircraft. The turbo-supercharger principle, using exhaust gases to drive a compressor, evolved directly into the turbocharger systems used in modern aircraft. Jets replaced piston engines, but the fundamental concept of recovering energy from exhaust gases remained valuable. Modern turbofan engines use sophisticated turbines to extract energy from exhaust, driving large fans that generate thrust. The direct lineage from the R2800's turbo-supercharger to these modern systems is clear. The automatic control systems developed for the P-47 pioneered automatic engine management. Before the turbo regulator, pilots manually adjusted engine settings, monitoring multiple gauges and making constant adjustments. The P-47 system proved that automatic control was not only possible, but superior to manual control. Post-war aircraft increasingly incorporated automatic systems, eventually evolving into the full-authority digital engine control systems used in modern aircraft. The materials science advances required for the P-47's turbo-supercharger drove broader developments in metallurgy. The high-temperature alloys developed for turbine wheels found applications in jet engines where even higher temperatures were encountered. The manufacturing techniques perfected for precision engine components enabled the production of increasingly complex machinery across all industries. Perhaps most significantly, the P-47 demonstrated that brute force engineering, backed by superior industrial capacity, could overcome elegant design. German aircraft often featured clever solutions to engineering problems, using innovative designs to compensate for material shortages and industrial limitations. The P-47 took the opposite approach, used the best materials, the most powerful engine, the most robust construction, and overwhelming firepower. This philosophy influenced American military aircraft design for generations. The F-4 Phantom II fighter of the 1960s was large, heavy, and powered by 2 massive engines, but it dominated its era through sheer performance and capability. The F-15 Eagle of the 1970s continued this tradition, being larger and more powerful than any contemporary fighter. Even modern American fighters like the F-22 and F-35 reflect this design philosophy, prioritizing capability and performance over elegance or cost. The statistical record of the P-47 Thunderbolt tells a story of overwhelming success. Republic Aviation produced 15,686 Thunderbolts between 1941 and 1945, making it one of the most produced American fighters of the war. Only the P-51 Mustang was built in greater numbers among single-engine American fighters. P-47s flew 546,000 combat sorties in Europe, more than any other American fighter type. They destroyed 7,067 enemy aircraft in the air, third highest among American fighters after the P-51 and P-38. But the real dominance showed in ground attack. P-47s destroyed 6,000 armored vehicles, 68,000 trucks, 9,000 locomotives, and 86,000 railway cars. This destruction of German transportation infrastructure crippled the Wehrmacht's ability to move and supply its forces. The Thunderbolt's survival rate exceeded all other American fighters. Loss rates per 1,000 sorties were consistently lower for P-47 units than for units flying other aircraft types. Pilots flying P-47s had a measurably better chance of surviving their combat tour than pilots in other fighters. This superior survivability came from the aircraft's rugged construction, powerful engine, and ability to absorb battle damage. 61 P-47 pilots became aces, meaning they achieved 5 or more confirmed aerial victories. Many more achieved ace status flying multiple aircraft types, with several of their victories in Thunderbolts. The top P-47 ace, Francis Gabreski, scored 28 of his 31 total victories in the Thunderbolt. Robert Johnson scored 27 victories exclusively in P-47s. The aircraft served with 15 Allied nations during and after the war. Brazil, France, Mexico, the Soviet Union, and the United Kingdom all operated P-47s during World War II. After the war, many nations continued using Thunderbolts, with some remaining in service into the 1960s. This longevity speaks to the aircraft's robust design and continued utility even as jet aircraft became standard. In terms of cost effectiveness, the P-47 proved economical despite its size and complexity. The flyaway cost of a P-47D in 1944 was approximately $85,000, roughly equivalent to $1.4 million in 1944, $2,025. This was higher than simpler fighters but far less than twin-engine aircraft. Given its superior survivability and multi-role capability, the P-47 represented excellent value. As World War II drew to a close in Europe, P-47s were everywhere. They flew cover over the Rhine crossings, attacked German positions in the Ruhr, and ranged deep into Germany, destroying anything that could support the Nazi war machine. By April 1945, the Luftwaffe had effectively ceased to exist as a fighting force, and P-47s increasingly focused on ground attack. When Germany surrendered on May 8, 1945, P-47 pilots had compiled a record of achievement unmatched by any other ground attack aircraft in the European theater. They had helped win air superiority, making Allied ground operations possible. They had destroyed much of Germany's transportation infrastructure, crippling the Wehrmacht's mobility, and they had provided close air support to advancing Allied armies, attacking strong points and enemy concentrations whenever called upon. In the Pacific, P-47s continued fighting until Japan's surrender in August 1945. While the Thunderbolt never achieved the same dominance in the Pacific as it did in Europe, it served effectively in the theater's unique conditions. The final combat sorties flown by P-47s occurred in the closing days of the war, attacking Japanese positions and supporting Allied forces. After the war, many P-47s were immediately retired or sold as surplus. The advent of jet aircraft made piston-engine fighters obsolete for frontline service with major powers. But many air forces continued operating P-47s, particularly those nations that couldn't afford jet fighters. The Thunderbolt served in various capacities, from fighter-bomber to reconnaissance aircraft to advanced trainer. The last P-47s in military service flew with air forces in South America, where they remained operational until the early 1960s. By then, the Thunderbolt had served for 20 years, an impressive longevity for any combat aircraft. When the final P-47 was retired from military service, an era had truly ended. But the Thunderbolt's legend was just beginning. As aviation historians examine World War II's air campaigns, they increasingly recognize the P-47's crucial role. While the P-51 Mustang captured public imagination with its sleek lines and long-range bomber escort missions, historians noted that P-47s had flown more sorties, dropped more bombs, fired more ammunition, and destroyed more targets than any other American fighter. Today, only a handful of P-47 Thunderbolts remain airworthy. These precious survivors are maintained by dedicated organizations and individuals who recognize their historical significance. Flying one of these restored Thunderbolts offers a unique perspective on what made the aircraft special. Modern pilots who fly restored P-47s consistently describe the same characteristics that World War II pilots noted. The aircraft feels heavy and solid, quite different from lighter fighters. The controls are heavy, requiring real physical effort to maneuver at high speeds. The massive radial engine dominates the forward view, requiring pilots to snake during taxi to see ahead. But once airborne, the Thunderbolt reveals its qualities. The engine pulls strongly, the aircraft climbs steadily, and as speed builds, the heavy controls become more responsive. Dive the aircraft, and it accelerates with frightening rapidity, building speed far faster than lighter aircraft. Pull into a climb, and the Thunderbolt zooms upward, converting speed to altitude with impressive efficiency. One of the best preserved examples is the P-47D Tar Heel HAL, maintained by the Planes of Fame Air Museum in California. This aircraft has been restored to pristine condition and flies regularly at air shows. Pilots who fly it report that the aircraft handles beautifully despite its size, and the R2800 engine runs smoothly and powerfully even after 70-plus years. Another notable survivor is Razorback, a P-47D that saw combat in the Pacific Theater. This aircraft has been restored to its wartime configuration, complete with combat markings and authentic equipment. Flying it provides as close an experience as possible to what World War II pilots encountered, though of course without the stress of actual combat. Museums around the world display P-47s, preserving the aircraft for future generations. The National Air and Space Museum in Washington, D.C., displays a P-47D in the colors of Francis Gabreski's aircraft. The Royal Air Force Museum in London has a P-47 that served with the RAF. The Musée de l'Air in Paris displays a Thunderbolt that flew with Free French forces. These static displays serve an important educational purpose, allowing people to see and appreciate the Thunderbolt's massive size and purposeful design. Standing next to a P-47, one can truly appreciate the engineering achievement it represents. The huge radial engine, the heavy wings, the sturdy landing gear all speak to an aircraft designed for combat and built to survive. The secret of the P-47 Thunderbolt wasn't really secret at all. German intelligence knew about the R2800 engine and its turbo-supercharger system. German engineers understood the principles and recognized the superiority of the American design. The secret wasn't hidden knowledge. It was the industrial and technological capability to turn that knowledge into reality. America in World War II possessed the most advanced industrial infrastructure in the world. American factories could machine parts to precision tolerances in quantity. American metallurgists could develop alloys with precisely controlled properties. American engineers could design complex systems and see them manufactured reliably. This industrial might, combined with vast natural resources and a population committed to victory, was the real secret weapon. The P-47 Thunderbolt embodied this advantage perfectly. It wasn't the most elegant fighter ever designed. It wasn't the most maneuverable or the fastest in level flight, but it was immensely strong, incredibly powerful, and utterly reliable. It could be mass-produced in quantities that overwhelmed the enemy, and it could be flown by rapidly trained pilots who could survive long enough to become effective combat aviators. Franz Dietrich, the German intelligence officer who examined that captured P-47 in France, survived the war and eventually emigrated to America. In the 1960s, he worked as an engineer for an American aerospace company. One day, attending an air show, he saw a restored P-47 perform. As the Thunderbolt roared overhead, its R2800 engine producing that distinctive deep rumble, Franz felt a familiar mixture of admiration and remembered despair. After the show, he approached the aircraft and spoke with the pilot. Franz identified himself and explained that he had once examined a captured P-47 for German intelligence. The pilot invited him to look over the aircraft, and Franz spent an hour reacquainting himself with the engineering masterpiece he had studied decades before. "We knew we couldn't copy it," Franz told the pilot, "not just the engine system, but the entire approach. You Americans built aircraft the way we couldn't, with materials we didn't have, using manufacturing techniques beyond our capabilities." The P-47 wasn't just a better fighter. It was proof that you had already won the industrial war, which meant you would eventually win the shooting war. The pilot nodded thoughtfully. "A lot of guys who flew these in combat said the Jug wasn't the best fighter in the sky. They said the Mustang was prettier, the Spitfire was more graceful, the Zero was more nimble. But when the shooting started, when the flak was flying and the Germans were attacking, they wanted to be in a Thunderbolt, because the Jug would bring them home." Franz smiled. "That was our problem exactly. We could shoot down P-47s. We could damage them badly, but we couldn't shoot down enough of them. And the ones we damaged too often made it home. Your pilots survived, gained experience, got better. Ours died, and the replacements had less training, less fuel, less hope." The P-47 wasn't just an aircraft, it was a system for turning American industrial power into control of the sky. This conversation, recalled years later by others who were present, captures the essential truth about the P-47 Thunderbolt. The secret engine that shocked the Germans wasn't shocking because it was mysterious or incomprehensible. It was shocking because it represented a level of engineering sophistication and industrial capability that Germany, for all its technical innovation and engineering talent, simply could not match in the desperate circumstances of total war. The Pratt & Whitney R-2800 double Wasp engine remained in production until 1960, long after the P-47 had retired from military service. Over 125,000 R-2800 engines were manufactured, powering not just Thunderbolts but also the F-6F Hellcat, F-4U Corsair, A-26 Invader, B-26 Marauder, and many other aircraft. It was used in civilian aircraft after the war, powering airliners and cargo planes. Some R-2800 engines are still flying today in restored warbirds, a testament to the engine's robust design and quality construction. The turbo-supercharger technology pioneered in the P-47 influenced all subsequent high-altitude piston engine development. After the war, the General Electric turbo-superchargers used in P-47s were studied intensively, and the lessons learned were applied to both civilian and military aviation. When turbocharged piston engines became common in general aviation aircraft in the 1970s and 1980s, they benefited directly from technology developed for the Thunderbolt. More broadly, the P-47 demonstrated principles that shaped military aviation for generations. It proved that survivability was a crucial combat characteristic, perhaps more important than pure performance. It showed that multi-role capability added tremendous value, allowing a single aircraft flight type to perform multiple missions. It validated the American approach to aircraft FT design, emphasizing robust construction, powerful engines, and heavy armament over lightweight and maneuverability. These lessons influenced every American military aircraft FT designed since. The F-4 Phantom II, designed in the 1950s, was large, heavy, and multi-role, much like the Thunderbolt. The A-10 Thunderbolt II, designed in the 1970s specifically for close air support, was deliberately named to honor the P-47 and embodied many of the same design principles: rugged construction, heavy armament, and exceptional survivability. Even modern stealth fighters, which must compromise some robustness for radar and visibility, still reflect the P-47's emphasis on survivability through their advanced defensive systems. Behind every statistic, every mission report, every technical specification were men who climbed into P-47 Thunderbolts and flew into harm's way. They came from farms and cities, from wealthy families and poor ones, from every region of America, and from allied nations around the world. They ranged in age from teenagers to men in their 30s. What united them was courage, skill, and a willingness to risk everything for victory. Many never came home. Despite the P-47's excellent survivability, hundreds of Thunderbolt pilots were killed in action, shot down by enemy fighters or ground fire, lost to mechanical failures or bad weather, or captured and imprisoned. Each loss was a tragedy, a young life cut short, potential unfulfilled. The cold statistics of victory and defeat cannot capture the human cost of the air war, but thousands did come home. They returned to build families, start businesses, pursue education, and contribute to their communities. The confidence gained from mastering a complex, powerful aircraft and surviving mortal combat served them well in civilian life. Many became leaders in their fields, drawing on the leadership skills and coolness under pressure developed in the cockpit of a Thunderbolt. As the years passed and these veterans aged, they gathered at reunions, sharing memories and honoring fallen comrades. They welcomed the younger generations who restore and fly P-47s today, passing on their knowledge and their stories. Each year, fewer remain. The youngest World War II veterans are now over 95 years old. Soon, none will be left FT who actually flew the Thunderbolt in combat. This makes preserving both the aircraft FT and the stories of those who flew them increasingly important. Organizations dedicated to World War II aviation history work to document veterans' experiences before they are lost forever. Oral history projects have recorded thousands of hours of interviews with P-47 pilots, mechanics, and others involved with the aircraft. These recordings, along with written memoirs and official records, ensure that future generations can understand what these men accomplished. When historians assess the most important aircraft of World War II, the P-47 Thunderbolt must rank near the top. While it may not have the romantic appeal of the Spitfire, the sleek beauty of the Mustang, or the revolutionary nature of jet fighters, the Thunderbolt's contribution to Allied victory was immense and undeniable. The P-47 helped win air superiority over Europe, making possible the strategic bombing campaign that crippled German industry and the ground campaigns that liberated occupied territory. It destroyed more ground targets than any other Allied fighter, directly supporting ground forces and interdicting enemy supply lines. It brought unprecedented numbers of pilots safely through their combat tours, preserving the experience and expertise needed for continued operations. But perhaps most significantly, the P-47 represented American industrial and technological power at its peak. The aircraft itself, and especially its revolutionary turbo-supercharged engine system, demonstrated capabilities that America's enemies could not match. This wasn't just about one aircraft foot or one engine. It was about an entire industrial system capable of designing, developing, and mass-producing advanced technology, while simultaneously fighting a two-front global war. Germany had brilliant engineers and designers. The Luftwaffe included some of the most skilled pilots in aviation history. German industry produced innovative aircraft throughout the war. But Germany couldn't match America's ability to turn advanced technology into mass-produced, reliable, combat-effective systems deployed in overwhelming numbers. The P-47 Thunderbolt, and specifically its secret engine system that the Germans couldn't copy, stands as a symbol of that decisive advantage. More than 80 years after the first XP-47B took flight, the Thunderbolt's thunder still echoes. Every time a restored P-47 flies at an air show, its R2800 engine rumbling deeply across the field, it connects the present to that desperate time when the fate of the free world hung in the balance. The aircraft reminds us that freedom was not free, that victory required not just courage and sacrifice, but also industrial might and technological superiority. The secret engine that shocked the Germans was secret only in the sense that it represented capabilities they could not replicate. The turbo-supercharger system that gave the P-47 its devastating high-altitude performance was the product of years of engineering development, supported by the world's most advanced industrial infrastructure, and drawing on resources from across a vast continent. It was a system that could only be produced by a nation with America's unique combination of technical expertise, manufacturing capability, and material abundance. That this system was installed in a fighter aircraft FT weighing 7 tons, armed with 8 machine guns, and capable of carrying bombs and rockets while still outperforming most opponents, speaks to the genius of Alexander Kartvel's design and the excellence of Republic Aviation's engineers and workers. That 15,686 such aircraft F-2 were produced in less than 4 years, while America simultaneously built thousands of other aircraft FT types, hundreds of ships, millions of vehicles, and equipped armies fighting on multiple continents, speaks to the unprecedented industrial mobilization that won World War II. The P-47 Thunderbolt was more than an aircraft. It was a weapons system that combined advanced technology, robust engineering, and overwhelming numbers to achieve air superiority. It was a tool that allowed America to project power across oceans, to protect its bombers, to attack enemy forces, and ultimately to help win the greatest conflict in human history. To today, when we see a restored P-47 Thunder across the sky, we're watching more than a vintage aircraft. We're seeing a monument to American industrial power, to the courage of the men who flew them, and to the ingenuity of the engineers who created them. We're reminded that freedom must sometimes be defended by force, and that the nations who possess both the will to fight and the means to build superior weapons hold a decisive advantage. The thunder of the P-47s. Pratt & Whitney R2800 engine, amplified by the turbo-supercharger system that so shocked German engineers, was the sound of American power in World War II. It was the sound heard by German soldiers scrambling for cover as Thunderbolts dove to attack. It was the sound heard by Allied troops grateful for air support. It was the sound heard by American bomber crews, knowing that escort fighters were nearby. And it was the sound that announced to the world that America had the technological sophistication and industrial might to build weapon systems that enemies could not match. That sound, that thunder, echoes still in the handful of surviving P-47s that fly today. As long as even one Thunderbolt flies, powered by an R2800 engine with its revolutionary turbo-supercharger system, the legend lives on. The secret engine that shocked the Germans remains a testament to American engineering excellence, a reminder of the technological edge that helped win World War II, and a symbol of the debt we owe to those who designed, built, and flew these magnificent aircraft into battle. The Thunder will not be forgotten. The P-47 Thunderbolt, in the secret engine system at its heart, will forever represent a pivotal moment when American technology, industry, and courage came together to help save the world from tyranny. That is the true secret. Not just an engine, but what that engine represents about a nation's capabilities, determination, and resolve. The Germans couldn't copy it because it was more than metal and mechanisms. It was the physical embodiment of America at its finest hour,